Boop. There we go. So they give you, for example, 4/7, 7/13. And
Wait.
am I looking at the right one? Oh, number 12, sorry.
Yeah.
Right. 5/11, 5/9. I was looking at 13. And 5/13. Okay.
Yeah.
Now listen, guys. Listen. Guys, what's true about each of those fractions? What's common?
5.
The 5.
Numerator.
Okay. If I take a number and divide it by something,
Oh, it's gonna be smaller.
and then I take the same number and divide it by a bigger thing, right?
It's gonna be smaller.
Okay.
The greater the denominator is.
Yeah. So this one's not as bad because all the tops are the same. So 5 divided by 9 versus 5 divided by 11. Yeah, you know which one's bigger, which one's smaller.
And then
Is that
I don't understand.
Good.
Yes, the next one, I understand this one now, but
All right, now the next one has got
it's weird.
different tops.
And bottoms.
7, 8, 6, 7, 8, 9. I think we talked about this specifically. If I take 1/2 and I add 1 to the top and bottom, which is just me saying that I want to do that. It's not saying that math allows that for whatever. What fraction do I get? I get 2/3. Is 2/3 bigger than 1/2?
Yes.
Sorry.
Yes.
Can you say that less confident? Yes. Okay. 2/3 is definitely bigger than 1/2. I like it. In fact, that will continue to happen.
Oh.
I'm almost certain we talked. I can't remember now if we did. I feel like that came up.
We did. I think
Yeah.
touched on it.
But this one's definitely a lot easier. Tops are all the same. This one's just the idea. I really want this to make sense. If I just keep adding 1 to the top and bottom, wouldn't I eventually get something like this? Right? Right? And isn't that just almost freaking 1? Isn't that almost 1? Do you guys agree with me? So the more you keep doing that, the closer the answer will get to 1. And if you start at 1/2, it's increasing all the time and slowly approaching 1. It's kind of neat. Okay. Whenever I say neat, I really just mean, at least for myself. No idea if anybody else agrees. All right. Anything else from homework stuff?
Me.
Yes.
Number 33 on, let me go. Let me get it up.
Yep.
No, I'm doing it right now.
How's everybody else? Everybody else okay? Relatively? Is everybody else doing really bad? I'm sorry. Is it that kind of time of year? Is it like all the essays due now and all the?
Yes.
I know like the next round of tests have been happening and all this kind of stuff.
Yeah. 6.2b
6.2b.
on number 33.
This is one about classroom of 25 students.
Yes, that one. The tutor and I couldn't solve that one.
Let me put this up here. Panasonic. Who's got essays due? Anybody have essays due? Who's got projects due? Any projects due. Just got a test coming up in another class. All right, see what I've done? I've tried to, do we have a test today? Do we have a quiz today? Yes, do you have a question?
No, see, my stressor is, applications to transfer, open up.
Applications to what?
To transfer.
Oh, yeah, that's a good point.
So that's like the main thing.
Anybody else in that same,
Not yet.
oh, not yet? Okay. I know how it is. I remember, I still have the first letter I got from from a university, saying, hey, you wanna apply to us? I still have it somewhere in some box. I remember that. All right, 33. Back in the day when we sent letters and stuff. I know. So this one says, you got 25 students, 5 rows, 5 columns, that's crazy. They could rearrange themselves by having each student move to a new seat directly in front or back, or directly to the right or left. No diagonal moves were permitted. Each student had to move to a new seat. Oh, okay. I like it. So, this one's just, if you draw it out and you think about it, and again, when you face a problem like this, the least important thing, and it's still important, but the least important thing is the answer. The most important thing is, do you even know what to try to do?
That's the thing. We didn't even know what to try to do. We couldn't understand the problem. Neither could I. And I drew the circle, and I drew the box with 25, but with the whole directions moving from the corner to down to left, none of it worked. So yeah, I didn't know what to do. Not even the tutor. And the tutor's name was
So like if we had 25 students in here, could everybody end up in a new seat if everybody moved so if everybody in this row moved up 1, obviously this person would have to move over 1. And then everybody in that row is gonna have to move down 1, right? Do you get to the point where you were understanding?
No,
Again, now listen, what I just said, did it make sense?
no, I didn't understand it.
Okay, so if we had 25 people in here, and everybody in this row decided to move 1 seat up, which they're allowed to do, right? Everybody can move 1 seat up, 1 seat back, 1 seat left, 1 seat right, they just can't move diagonally. Yes? Okay. The person sitting here, what are they gonna have to do if everybody moves up?
They're gonna have to move down.
No, there's somebody in the seat. Every person in here is moving up, moving up, moving up, moving up. This person has to,
They have to move left or right.
yes. You understand?
Okay.
But then what's gonna happen in that other row?
The other row, they're gonna have to go either up or down.
If they all decided to go down, then the last person is gonna have to go
Right.
over. And then that last row, if everybody moves up, is this person got a place to go? No. Does that mean it's not possible?
It's
No,
not.
that was just my first kind of attempt at this. So, give me some tries with this problem.
But how?
Don't spend a ton of time on it. It really is just more about, can you set it up? Can you see if there's something that makes this quicker?
Because this is what I did in the box when we were drawing it out with the down.
Sure.
And we both figured out there's no way this is
It might not be possible, and if you try a couple times, you might see that there's something that makes it not possible. I don't want to give anything away. So if you think it's not possible, you have to give me enough reasoning to show me how you determine that. Yeah?
Yeah, in the corner,
Okay.
there's nowhere the person in the corner can go anywhere.
Okay. Then that'll be your answer. But you got to give me just enough to see what you thought about to get there. Anything else? Homework? Okay. All right. Nope. Yeah.
So you said that I did 6.1, number 6D wrong. On set A. Yeah,
Okay.
6.1.
Did I say you did it wrong?
Yeah, you did.
Let me
You,
see.
you gave me a question mark.
Oh, I needed you to explain. I didn't say that was
How?
wrong.
Wait, so how would I explain?
Well,
That's not the best I could explain.
all you did was write 1/3 down.
Yeah, and that was it, because that's 1/3, that's it. Because of a year, that's a year's 365 days.
So I need to see the connection, and it could be really simple. If I sleep 1/3 of the day, every day, then how much of the year do I sleep? Yes.
Would you multiply by?
No, they don't want a total number of hours. So watch this. If I had, all right, 3 chocolate bars, right? How do I say this? Yeah, in a package, right? There's a package of chocolate bars. There's 3 chocolate bars in a package. And I eat 1/3 of each. Yum, 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 yum. How much of the package did I eat?
1/3.
1/3 of the package, right?
So basically you sleep 1/3 of a year.
But I need to see that connection.
Like in a picture?
Yeah, you can even say like this is a day, and you sleep 1/3 of the day. So then if you sleep in it, and you don't have to draw like 365 of these, but
So
it's actually looks sort of like a bed, but I'll.
I could just draw day 1, day 2, and
Yeah, and then say it would continue, so if you do 1/3 of each day, you end up doing 1/3 of the whole year. Yeah. Okay.
And then you said that we're not on decimals, right? Because I was doing number 9A, 9B, 9D, all that
Yeah,
stuff.
I don't wanna, you can't bring decimals in. When they say compare fractions, they gave us
But then how?
several different ways to compare fractions. You can't bring them to
Cross
decimals.
multiply. If you
Yeah,
allow
cross
that.
multiply, yeah.
But then what about if I have 3 fractions?
Say again?
3 fractions, and number 12.
What are they asking you to do? If they're asking you to order them? Oh, we had just talked about this, yeah. Okay. We didn't, that must be from a different section, real quick. So Andrea, we just did a problem earlier where we had to order these. Right, there was another problem that said this, order these.
Uh-huh.
And this one is relatively easy, because if I have 5, and I keep dividing it by a bigger number, what's happening to the result?
The result is getting bigger.
No,
No, it's getting smaller.
right? So like, for example, let me get, what's 20 divided by 2?
10,
What's 20 divided by 4?
5,
What's 20 divided by 10?
2.
What's happening to all your answers? Aren't they getting smaller?
Yeah, they're getting
Okay.
smaller.
So what would the smallest number up here be?
The smallest number up here would be 513.
Yes, okay, that one's easy. The one you were just asking me about, what did it look like again?
It's for 12, it says 1117, 1317, and 1217.
Now this one's even a little more direct. Which one's bigger? Who's
Well,
got,
Oh, that one, I guessed it. We learned this. It's this one is bigger. It's 1317, so therefore it will have the smallest.
wait, what's the biggest one?
The big 1317.
Yeah, okay, so why did you bring decimals into it?
I just wanted to show if you wanted more work. That's
No,
why.
no, that's the problem. Don't bring decimals in, you're not allowed to yet. Yeah.
Oh, okay. But then how do I do for 9A? You put in A over B equals C over D. And this one for number 9.
I'm trying to remind you. So guys, help me out, guys. How would I check to see if these two fractions, how would I check to see if these two fractions are the same? Guys, how would I check to see if those two fractions are the same?
You cross multiply.
Cross multiply. Yeah. So that's what I'm saying to you, right? That's the A, B, C, D thing I told you about. So I'm trying to remind you about all the methods we learned to compare fractions, to see if they're equal, to see which one's bigger, which one's smaller, right? So 18 times 4, 72. 7 times 11, 77.
Yes, that one I get that.
So this is not equal.
Yeah, they're not equal.
So just, you know, on that one I understand, you might have done the decimals just to kind of check yourself, but don't even show those to me. I don't want to see decimals. I want to see what we've learned just dealing with fractions, how to compare them.
And I have to do it with 15.
All right, so.
With 15 because I did the whole break.
Yeah, you can't bring fractions in to do the work. I mean, decimals.
So I just circled the decimals or not circle the decimals?
No.
Because it's the
Redo
thing-
the problem without looking at decimals at all.
Because the thing was, they wanted 1/9. I was, with the decimals, I was able to get the fraction formed in the calculator.
I know. That's fantastic. If only we knew decimals. We don't yet.
Mm,
So you have to have a way to do this with only fractions. We're not bringing decimals in at all.
only fraction, so I have to do the same. I have to do cross multiply
Yes,
for
and
15.
so you can come early next time if you want to go over some more from the homework.
If only I can. My driver, Miss
Well,
Elizabeth,
or stay after. It's fine.
I'll stay after.
Okay. Anything else from homework? All right. Okay. Let's see if I can keep these guys up there.
What is that?
Huh? This is my contribution here. It's kind of summed up how I've been feeling. This is Emma's contribution. Right? Steph. He makes Stevia the sugar replacement. And this, of course, is pumpkin tree. Oh, pumpkin tree? Okay. All right, guys. Now, we got one more section in chapter 6, right? May. Can you draw a representation of this in like one big picture? Can you draw a representation of 3/5? Maybe using, let's all use a rectangle.
Welcome.
All right. So if I were to do this, pretend like those are all equal. This poor little thing is melted. All right. And then you could shade in
3.
I love it. Now, what does it mean visually? If I said, so what was the first thing we did? Wasn't the first thing you did to cut that thing in fifths? You cut that thing in 1/5, so you took 1/5 of it, right? So what does it mean to multiply something by 1/5? It means to cut it into 5 parts and look at one of them, right? So this part right here is 1/5 of the total picture. Ooh. What if I then said, let me do it over here. Cut this in half. All green, you barely exist. Cut this in half. Now, there's a few different ways to do that in the picture, but there's one way that makes the most sense. You want to cut everything in the picture equally in half. Yes, there you go. That's what that is, right? Okay. So if I take half of 3/5, so isn't this 3/5? Yes. So half of 3/5 is this. What is each of these little blocks? How much is each of these little blocks?
1/10.
Oh, yeah.
Yeah, it's 1/10, right? And of course, how many do we have? 3 of them, so this is 3/10, which we already should have known, right? When you multiply fractions, you multiply across. But that's a nice visualization of multiplication of fractions. Now, that's a really simple example.
I had a question. So when you cross multiply, are you allowed to like simplify them?
Alright, so a couple things. We're not cross multiplying yet.
Oh, okay.
Do you mean about the earlier one we did?
Yeah.
Oh, well, the earlier one we did, we just got that single number.
Oh, so you can't like.
So I wanna make sure, I'm not cross multiplying here at all, right? It's 1 times 3 and 2 times 5. You with me?
Yeah.
Alright, there are, let me just say this real quick. There is one time that cross multiplication works directly. And that is when you have fraction equals fraction. Right? You guys with me? You remember problems like this?
Yeah.
And how did you solve it? Cross multiply. But then students kind of like cross multiplication, understandably, because when you do it, the fractions are all gone. So then, understandably, the optimistic part of your brain says, let me just do that shit everywhere. Right? Sounds great. But it doesn't work anywhere else. In fact, real quick, stay with me. Do any of you know why it works? Y'all know to do it. Do you know why it works?
It's division. When you multiply, you cancel division. Cancel division.
All right, I like it.
Plug in.
I like it. Let me take this. So let's just focus on this just for a second. I already forgot what I put down here. I think it was this. Like if I multiply both sides by 3, why is that a good thing?
You
If I multiply both sides by 3, what good thing does that make happen?
take away the 3,
This fraction will
turn into a.
stop being a fraction, right? I love it.
X will be isolated.
So multiply both sides by 3. If I then multiply both sides by x, that's a good thing because this other fraction will cease to exist. So these die, these die. What does it look like happened? Doesn't it look like the 3 just came up here?
Yeah.
Doesn't it look like the x just came up here?
Yeah.
So cross multiplication is just a shortcut for killing denominators, right? It's a beautiful thing about equations. When I teach solving equations, I try to get students to understand. Identify what you don't like in the equation, and then think, can I kill that? Right? I don't like that. I mean, it's not a good life lesson, right? Please, dear God. But I mean, in an equation, you can kind of cancel the stuff that you don't want to look at. So if you don't want to look at the fraction, you can kill it. Multiply by its denominator. Okay, enough of that. Try to represent this real quick. What you got, Jeff? 1/3 times, become a 3. 3/4. I like it. Don't do it, just represent it visually. Can you represent that visually? Start with the 3/4, by the way, that's gonna make it. Draw a 3/4, and then cut it in thirds.
Does it have to be in any shape in particular?
Rectangle's easier because other shapes, it's harder to get the areas to be the same. Does that make sense?
That makes sense.
Yeah. Circle's probably not bad, but it's hard to cut that thing in half correctly, right?
But then how do you cut it in 1/3?
Rectangle.
So how do I represent 3/4?
Oh, that's easy.
It's easy, right?
Yeah. You just shade in the 3. But then the one thing I'm asking is how do you like split into 1/3?
Yeah, so how do I cut this into thirds? How do I cut it in half? We did that earlier. I love it. Everybody's like, how do I cut it into thirds then? How many partitions do I make?
Well, 2
So
lines.
2 lines, dude.
2 equally spaced. Now I want brownies. Damn it. Nobody else wants brownies?
What?
Does anyone look at this and think brownies?
No.
You guys ever make brownies?
I see
You're
you
chopping.
chopping.
You're chopping.
Oh,
You're like, how
like,
big do I want my brownies to be? How many cuts do I want to make?
I just think of Hershey bars.
Okay.
Later.
But I do also think of brownies.
All right, I'm sorry. I just wanted to share. So we cut it in thirds, right? And I want one of these thirds. So how much is this? How many, let's go with it. How many brownies are there? 12 total. So each one of these is 1/12. And then how many are in this? Is everybody cool with that? This is 1/3 of the shaded region, yes? So, but what is that? That's 1, 2, 3/12, which of course is? You're dead from the other day.
1/4.
1/4. All right, I like it. Let's stop for a second. See, we kind of like pictures, right? Visualizations are good. Little people really love pictures. They kind of latch on to it, especially when you have them like construction paper and you're like, can you cut this into 3 equal parts? So they get the idea of what 1/3 means. I like it. Now up here, you guys remember what we would do to make this like a little bit more direct? You can cancel the 3's, right? Yes? Because isn't this 1 times 3 divided by 3 times 4? Isn't that 1 times 3 divided by 4 times 3 because of commutivity? So don't the 3's then cancel? Now that looks like it takes longer, but I would just do this shit and say 1/4 is the answer. I mean, right? To explain it takes longer, and then you go, this is what you do. Oh, I like it. Okay, maybe. Okay. All right, so that's some basics about that. All right, let me give you, I'm gonna learn from I'm gonna give these to you immediately. All right. Let's see, how you guys gonna pair up? You wanna pair up the same way? I don't know. You get that thing,
I don't know, offense, but I'm ready to erase that thing, so. I'm not even.
Put a few more bits in there. Everybody's got some, right? You got more people. You got more. Can you guys, can you represent for me, this is going back a ways actually, can you represent for me 6 divided by 3? So this is not fractions, you're only going to use what part for a whole number, yeah. So can you represent 6 divided by 3? What would you do?
I think I have enough, dude.
Hopefully you got 6, right? Let me know if you don't have enough.
Oh, you got 6, cool.
So what are you guys doing to do 6 divided by 3? How can you do that? Sure, what do you do? Sorry. How do you do 6 divided by 3?
You said.
Put them into equal groups.
Yeah, good. Remember there's 2 ways to think of it, measurement, sharing. Sharing's a good idea because we got 6 total parts. Divided by 3. So what's one way you can do that? You can break it up into 3 groups, yes? Yes?
Yes.
And then how much is in each group?
2.
So you're publishing, right? So, where do the fractions come in? Okay, so is everybody cool with that? Or you could think of it as, if you give 3, how many groups would you need? 2 groups, yes? Those are the 2 main ways to do the division. Either way you do it, you get 2. All right, so take the 1 right there. Actually, let's do this. Take 2. And you divide that by 1/3. Let me remind you guys. 6 divided by 3 was 2 because it took 2 3's to make all 6. Right? That's one way to look at it. Say again, sorry. Yeah, I'm sorry, yeah. 2 divided by 1/3.
Two divided by 1/3. Yes, please. I think 2 divided by 1/3 is 2.
I'm saying I wrote the groups as in
My brain.
third. Like it's in third.
I understand it when it's on the board, but not with these.
What are these?
So let me help out a little bit.
I'm a
6
little
divided
lost.
by 2.
Yeah.
Let's see, what did I say? 6 divided by 3? 6 divided by 3 is 2 because it takes 2 groups of 3 to make all 6, yes? So 2 divided by 1/3, how many 1/3s to make 2?
6.
Yeah, I love it. I gotta do the whole, hold on. Alright, there we go. That's funky looking.
Yeah.
Looking at me,
I got
alright.
it wrong.
Yes?
Yeah.
So 2 divided by 1/3 is 6. Now, would that be at all immediately obvious to somebody looking at 2 divided by
It
1/3?
wasn't obvious to me, so no.
No. What's one thing that tells you, based on what we talked about earlier when we were ordering 5 9s, 5 11s, 5 13s? What's one thing that tells you that that should come out bigger than 2? Because what's 2 divided by 1?
2.
So if I divided by less than 1, shouldn't the answer be bigger?
Yes.
Okay, so that level is good to discuss. Why would I expect the answer to be relatively big, right, relative to what's there already? Because I'm dividing by a very small number. And when you divide by smaller, the outcome is bigger. Yes? I like it, okay. Now, we're gonna talk more about the computational thing about why, do you guys remember when you divide fractions, you multiply by the? Alright, so we're gonna talk about why the hell we do that. This is a big key, I mean, right here, what happened? What is 2 divided by 1/3? Isn't it 2 times 3? Yeah, alright. Kick ass. Does that prove that you always know? It could have just been a coincidence. So later we're gonna actually prove it. Now, what about, here's my other example. Where's that other? How about this? Jeff. Where is my phone? There it is. Let's just use you. Let's use you. How can you do 2 times 3.5? How could you represent 2 times 3.5? So now we get to use another shape. I like that. So what you do remember is the second part that you make happen, and then what's 2 times anything mean?
Double it.
Double.
Take 3.5. Oh,
So get 3.5.
and multiply by 2.
So these together would be this.
Dudular. Alright, that's next side. I
Did
got
I
it.
do that correctly?
No, that's what dudular means. It means good.
Oh, okay.
I think she got it.
Okay, I like it. Does anyone else think they got it?
I think
That's light, bro.
You got it? Okay. You guys did it right over there?
Yeah.
Alright, let's see. 2 times 3.5, you would put 3.5 down. Come here. And then you want, what it is, yeah. And then I would have to get another set of 3.5. Right? You double what you got. And then of course, I love it, somebody went like this, and then went shabam, and there it is, that's the answer. Which is 7. So how does that work? Does anyone remember how that works computationally? Oh shit. What does 3.5 mean?
3.5.
Alright, let's not bring decimals in. What is, say again?
3 holes and a half.
I like it. Operation wise, does it mean 3 times a half? What does 3.5 mean? And remember we talked a little bit about this, that's the worst decision. It's in the top 5, I think, worst decisions of mathematics of all time. Because a number sitting next to something normally means multiplication, right? And then this, I don't know, let's just put the 3 next to the half, and we'll, it's the one time it doesn't mean multiplication. Oh, damn. You guys, am I with me?
Yes.
So what's another way to write this? What's wrong with writing it like this? Did I capture the thing right?
Yes.
No.
Oh, you're multiplying it.
I'm trying to double this thing, this whole thing, right? So it should be this, yes?
Oh, yeah.
Yeah.
I like it. And then what would you do, of course? So this will be 6, and what's 2 times a half? 1. And can you guys, do you guys think back? Isn't that exact? Doesn't this capture, didn't you double the 3? So you had 6 whole ones, and then you had 2 half pieces, which became a whole piece, yes? Right, right? So this exactly captures what the hell you do with the manipulatives. All right, my favorite sound. Top 5. Favorite. Okay. Now, what about, oh shit, what about this? You can go down. What do you guys think about this?
Yo.
Now, can you understand it would be evil for me to say represent that with your stuff, because I mean you could represent 3.5 easy. We did that earlier. Yes? How the shit do you represent this times that? Yes?
Yeah.
Alright, let me stop. You guys understand the problem here? When I have 2 mixed numbers, it's hard to tell. That first mixed number is not a whole number. If it's a whole number, that's awesome. I just double or triple, whatever the hell the number is, I just do it that many times, and then we can do just like we did. That first number's a freaking mixed number. What the shit? How do I represent this thing 2 1/3 times?
I'm be honest, I have no idea.
Okay, I got one suggestion is to make it improper, in which case we probably don't have enough pieces. What would this look like as improper fractions? Say again, sorry? Yeah, 3 times 2 plus 1. Real quick. Everybody knows that, right? 3 times 2 plus 1?
Oh.
You know what I'm about to say, don't you? What am I about to say?
Why does that happen?
Yeah, why does it work that way?
Why?
So remind me, what is 2 1/3? What does that really mean? 2 plus 1/3, how do you add those together? Don't you need LCD?
Yeah.
Won't the LCD, if I have a whole number plus a fraction, won't the LCD always be that? Whatever the hell that is. Whatever the hell that is, that's the LCD. And aren't I always going to multiply it by whatever the hell that is? Right, to make this have the LCD? And then aren't I gonna add whatever the hell that is? Yeah, maybe. So I'm gonna
I don't know.
multiply by 3, right? And then I'm gonna add 1. Isn't that exactly what the shortcut is? Multiply by 3,
Yeah.
add 1?
Same on.
Okay, I'm sorry. And of course, what's this guy? 7 halves, right? 2 times 3, 6 plus 1, 7. Now even this, what would you do?
Multiply
I don't know how to do that.
Please comment multiple. Cause I know that 3 times 2 can go into 6.
Well, 3 times 2 is 6.
It's
49.
Over
I need
6.
6.
No, 7 times 7.
Oh, is that 49?
49.
49. But how do I do this?
I have no idea.
Oh.
Do you wanna do it?
No.
Alright, so, guys, stay with me. We're just exploring, right? So that would be the way to do it computational.
Yeah.
Correct? Because the other way would have to involve, what we're about to do right now. So normally, I would not do this problem by hand the way we're about to do it. But isn't this 2 plus 1/3? Isn't this 3 plus 1/2? So isn't this 6 plus 2 times 1/2 plus 1/3 times 3 plus 1/3 times 1/2? Yes? Right, guys? Are you guys with me? You guys got real quiet. What happened? So all we did was,
Lots of fractions.
sorry? I didn't do it, I didn't do anything with fractions. Do you guys see that? I didn't do a damn thing. I just wrote them down, didn't I? I didn't do shit with them. 2 times 3 is 6. Okay, we're not gonna argue about that. 2 times 1/2 is 2 times 1/2. I haven't done anything with it yet, right? So please get to the point where you can at least just write them down. We haven't even done something with them yet. You guys with me?
Yeah.
So we all know how foiling works, right? And that's all we did. I haven't done anything yet. But couldn't you then show this visually? Obviously this is pretty simple, right? We did this earlier. 2 half pieces makes a whole. 3 1/3 of a pieces makes a whole, right? You could do each one of these visually, yes? And then this one, how would you do this?
Multiply it.
Sorry?
Multiply it.
Sure, but how would you do it visually? You don't even have to use manipulatives. Can you think of it the way we did earlier, right? Could you represent 1/3? Shade it in. And then cut that in half, right? What would that be? Of course, it'd be exactly what we know it to be. It would be what? 1/6. I like it. Yes, there you go. The little green dude. Or you could, if you wanted to do it visually, stay with me now. 1/2, right? There's 1/2. Now, can you cut that into thirds? How do you cut that into thirds? How do you cut this? Yes. So what is 1/3 of this then? It's this, which is 1/6. Okay, like it, maybe, maybe. Okay, alright. So to do the original problem visually is really, really not easy at all because you've got whole numbers and fractions, and then I know what 3 times something means. It means do it 3 times, right? If I have 3 2s, then I can just put 3 2s and get 6. But what the hell is 3 1/3 something? It literally means 3 times it plus 1/3 times it, which is why you have to look at it like this. Okay. Let me see, I think I've scavenged my notes here. Here. Right. Oh, okay. Let me see if I can give you one more to play with here. Can you tell me what? You represent this here. Well, I don't know if you have enough pieces there. Let's do 3 times 1/6.
Little. I like the triangles.
Yeah, see? you got 3. The 1/6 little triangle dude. Oh, what are you doing there? That's right, I got 32 triangles. 1/6 the triangle dude. If I have 3 of them, if I put them together, it makes a half. Right? And of course, I really hope that you guys already knew that was going to be the answer, right? Because what happens here? Can't I just, what happens with these two? If I do it computationally, what happens with these two? 3 goes into 6 twice, which is why we got 1/2, because that's the answer. Alright, let me give you something a little more interesting.
Let's go.
Can you do 2 times 1 and 5/6?
What?
4, 5.
I don't know if you guys, do you have enough?
I do not. Okay,
You might have to get a little creative.
No.
This is like beginning. 1, 2, 3.
So 2, that'll be.
So basically,
So then we have 2 and.
And then times 2.
1, 5, 6.
So what do you do if you don't have enough green? That sounds like a situation we're all in.
So 2. So this is the actual original.
So, oh, okay, so it does.
So I want 1,
Okay, this is the 2.
5, 6, right?
Whoa, right? Wait. So this is the original part.
And then I have to double that.
This is 1 and 2.
Huh?
Yes? Okay. So I can double this easy enough. But then how am I gonna double these if we don't have enough parts to it?
A half.
See it?
Get a half in there.
Yeah, I can put a half in place of these 3. Is that what you're saying?
Yes.
So then I can double the half and I can double the triangles. I just have to double everything. Yes? Can we stop for a minute? Are you guys,
Got it.
yeah?
Yeah.
You good?
Yes.
Okay. And again, it's it's really, alright, so for one thing is, I myself have never taught elementary school. I don't know if you guys are aware of this. I know, it's terrible. So I often feel a little bit like a bit of a sham in here, but it's just the way this is set up. So I'm really interested, I'm really curious. I have no idea what it's like to work with people, little tiny people, that have no idea what fractions are. And even if you hate fractions, you at least know what they are, right?
I do know what they are.
We just saw something. But, you know, the manipulatives would hopefully bridge that chasm, right? They're gonna come in not having a clue, but they gotta kind of grasp, they know cutting things in half. They know cutting things in parts, because it gets some freaking cake, and they're all happy, and they watch the parts getting cut, right? And they're like, that part's bigger than
Unless they
mine.
don't like cake.
Unless they don't like cake, and then there's pie, and if they don't like pie, I don't know. Pizza, sure, and if they don't like pizza, I really don't know what to do.
They make one of those cookies.
So I'm sorry, so everybody's cool with what happened up here?
Yeah.
What is this?
3 thirds, 1/4, 2/3.
I like it, so 3 and 4/6, which is also 3 and, yes?
2 times.
3 and 4/6, which is also, I swear, 3 and 2/3.
Cheers, mate.
Oh.
Cheers. So coming back to this, how would we do this by hand? There's a few different ways you can do this. It's gonna get a little weird here. So it's 2 times 1 and 5/6, right? 2 times 1,
2.
And then,
Um, 2 times 5, 6.
right? And what's kind of wrong with this? One thing I could do with this immediately is
Reduce
just
it by
reduce
2,
it.
and it'll be 5/3.
Didn't we at one point have, maybe not the way we did.
I can talk about that.
And what is 5/3? It's 1 and 2/3.
2/3.
So there's your 3 and 2/3,
Got
which
it.
is what we got, yes? You guys with me at all? A little bit? Okay.
Wait, why didn't you multiply the 2 to the denominator?
Why didn't I?
Yeah.
Okay, because it's not 2 over 2. It's 2 over 1.
Oh,
Yeah. So this is a big thing. This is something I'm gonna forget myself because
yeah, I like the 1.
But-
Thank you.
all the time when I'm teaching, actually it doesn't matter what level of math I'm teaching. When you put that over 1 in, students can kind of latch onto it better. If I multiply by 2 over 2, I'm really not, I'm multiplying by 1, right?
Yeah.
Okay. Alright. Oh. So what do you guys think about, the properties? Remember, we just did this the other day. What properties do we have that we've discussed so far? We had properties for whole number addition, multiplication. We had properties for fraction addition, subtraction. Now we have properties for fraction multiplication. What are these properties? They're closure, yes? So what do you think? When you multiply 2 fractions, do you get a fraction back?
Yes.
Yes. A whole number is a fraction because it's the over 1. What about, what's another property?
Are these all not?
Sorry?
Sorry, never mind.
Commutative, right? So what do you guys think about commutativity? Let's see, we kind of have proved this a little bit. Come back to the board. Alright. So the A over B times C over D. What is that equal to?
A.
Yeah, A times C over B times D, yes?
Yeah.
Now, what are A and C and B and D? What kind of things are they? What do we have to assume they are? No. A, whole numbers, right? The fractions are A over B. Fractions are ratios of whole numbers, where of course the bottom is not 0, right? So we don't make any freaking black holes. What do we know about multiplication of whole numbers? It is commutative. So of course I can just write this like this. Stop for a minute. So it's I like to say fractions inherit all of the properties because they are composed of whole numbers. So I know this hopefully is kind of obvious, right? But this is the real way to show, because is everybody cool with everything I've done? AC is CA, BD is DB, and then I can do this. So sure enough, what does that show is true? Yeah, exactly. It shows this. I like it. Exactly, it shows everything's good. All right. You can do something very similar for associative property, right? What about, what's, all right, one of the new things that we haven't talked about yet. Do you guys remember additive identity?
Yeah.
What was the additive identity? 0, because when you add 0, it stays the same. So obviously then what's the multiplicative identity? Way ahead. So the identity, multiplicative identity is 1. Now there's a brand new idea that we haven't talked about yet because we don't allow ourselves to consider negative numbers yet. So we haven't talked about the idea of inverse. So for example, just to go back, an additive inverse is what you add to something to bring it back to the additive identity. Right? So what would I add to 4 to make it become 0? Negative 4, it's crazy. Right? What would I add to C to make it become 0? Negative C. Right? So since this book doesn't let us use integers yet, we haven't talked about it. But I can talk about multiplicative inverse. So what should the multiplicative inverse do? It should multiply by some fraction and make it become the identity, 1. So what would I multiply a fraction like 2/3? What would I multiply it by to make it become 1?
3 over 2.
3 over 2. I love it.
This is what my sister was talking about yesterday. I was so confused what she was. And
Oh.
she just said reciprocal, and I was like, oh.
There you go. So the technical term for reciprocal is multiplicative inverse. I like it. Come by in. So what's the multiplicative inverse of 3?
1/3.
Holy shit. I like it. And you can see it happen. Here you can see it happen, right? 2's kill each other, 3's kill each other.
So, but,
You know, when I teach math, it's very first 6 seasons of Game of Thrones. It's very violent.
Like 300.
Things are killing each other.
So basically, it's like 300 the movie.
Sure, whatever violent thing you like best. That's what my math is like. All right.
negative 10.
So that's kind of a brand new thing, this idea of inverse, but you guys know about that. Let's go back to talking about division, I think. Let me see what I want to do next. Yes. Let me ask you this question. Let's see. I'm going to take this away. Where's my phone is completely pointed in the wrong direction. Not completely, okay. Yeah, what do you guys think about this? What's 14/15? Actually, let me start there. What's 14 divided by 7?
2.
Holy shit, right? Why?
Because
7 times 2 equals 14.
Yeah, it takes 2 7s to make 14, right? Okay. So what is 14/15 divided by 7/15? Be careful, be careful. Don't be that careful.
2.1.
It's 2. What is 2 7/15? If you add 7/15 to itself, what do you get?
1 whole.
Can you just be a little more specific? All right. Let me ask you this. What is 14x divided by 7x? You guys cool with that? What would happen there? 14x divided by 7x. 2, right? You guys with me? Because the x is canceled, right? Does it matter what the x is then? No. 14x divided by 7x is 2. So what's 14 5s divided by 7 5s? Isn't that freaking 2? Yes? Yes? Because what do the 5s do? They cancel. It takes 2 groups of 7 5s to make 14 5s. Yes? All right, stay with me on the left. Okay. So much about fractions. Now, this is not going to help you teach. It is going to help you understand. Because normally when you're doing elementary school, how many variables have they looked at so far?
Probably 0.
Probably none, exactly. Unfortunately, they should, but oh, that's probably why I shouldn't teach. But what I want you to realize what we just did, it doesn't freaking matter what this is, does it? It doesn't matter what x is, except it can't be 0, right? 0 equal 1. But it can be anything. So could it be 15ths? 14 15ths divided by 7 15ths? The 15ths cancel, you get 2. So the first kind of step into fraction division, you would want to take a step with the same denominator. Because you can explain it a lot simpler. So you can explain this is 2, the same reason this is 2. 2 7s make 14, right? 7 plus 7 is 14. The same way that 2 7/15ths make 14/15ths. Same way. Now, let's take a step up. into what we already know is true, how would we do this? Get out of there. How would I divide officially? And I'm going to show you why this is true in a minute, but you know the shortcut. How do I divide fractions? Multiply by the reciprocal, right? So can you see it now? The 15s are just going to cancel. And 14 divided by 7 is 2. That's sort of like that 14x over 7x I was trying to show you. The x's cancel. This one is in your face about why the denominators cancel. And in fact, here, this might even be a better place to start. What is something divided by itself? Something divided by itself. 1. So what is 1/15 divided by 1/15?
1.
So what is something divided by itself?
1.
So what is 1/15 divided by itself?
1.
1. So if I double this, shouldn't the answer double?
Yes.
Yes.
Okay, and then you can kind of work your way up to this kind of thing, yes? It kind of shows you why the 15s don't end up in the answer, because they're part of what I'm kind of dividing out. All right, maybe. So let me show you this. And this is the first book I have ever seen that actually shows what I'm about to show you, which is neat. Everybody's, all right. Did I say something offensive? What did I say? Did I say something bad? I don't know. I hope not. All right. If I have to do, all right, now watch. What I'm about to do, you would never do, okay? I'm about to show you why what we do works. I am not saying you will ever do what I'm about to do, yes? But I really want you to see, there shouldn't be anything that you're gonna teach that you really don't know why it works. I mean, that kind of makes sense, correct? Okay, and unfortunately I think, well, anyway, some of my colleagues might have some issues, but, again, none of us would ever do what I'm about to do. It's just gonna be explain why it works. What is something divided by something? Could I write that as a big ass division bar? Yes? Are you excited about this?
No.
All right. What do you hate about what I've written up there?
Fraction over fraction.
All right, here comes my dumb joke. It's like fracception, right? So it's fraction inside of a fraction. Thank you so much. Neither one of them has something that spins. I have no idea what level they're at. All right. What's the best number to have on the bottom of something?
A 1.
1. Yes, everybody agree? If there's a 1 on the bottom, it doesn't even need to be there. The 1's like, oh, you don't need me down here. You can just erase that shit. How do and we all know this. What would I multiply this by to make it 1?
So,
Not itself. That would be 16 over 81.
Oh.
The reciprocal, right?
9/4.
And if I multiply the bottom by 9/4, I better freaking multiply the top by 9/4. And down on the bottom, these cancel. Do you see? Are you guys with me?
Yes.
That is why it works. Yes?
Yes.
Raw, okay. It's not necessarily something you would ever show your students, but as long as you know that it works, there's a good reason why it works, then you can stand a little firmer when you're showing people that it works. And if the student's like, show me why it works, and you're like, okay, I'll show you, let me know if
Good
you
luck,
get
though.
this. No, you never know. Okay, and then of course, what do you get?
18.
Yeah, 3 goes into 9, 3 times. No? Are you guys? What's happening? 2 goes into 4,
3, 2.
so it's 3 halves. I lock it. Okay. Bum, 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 bum. Oh. Do I want to show that? Why not? Yeah, why not? Oh, yeah, that's right. Okay, sorry. Looking back at my notes. I'm gonna erase all this. I don't know why I'm trying so hard to keep the heart up there, but I am.
erase it. It's creeping me out.
If I had this,
You gotta go.
somebody help me out. Let's see if you guys were paying attention earlier.
A over B
A over C.
times.
A over C, well,
Over-
no, more
over
directly,
B
more directly. What was this? 14/15 divided by 7/15, what was that?
Times B over C.
No, come on, no, what was this?
What?
Two.
It was two. Did you do anything besides 14 divided by 7? Why? Because these were the same, yes?
To cancel.
Oh, shit.
Oh,
I-
14 of these divided by 7 of these is
It's
I
2.
swear I saw a D. I swear I saw.
Oh, you're okay, I understand.
My fault.
Alright.
What's AC?
So this would be A over C.
Over C.
I like it. What, let's look at this a little more, directly. So now let me do this for you, Louise. You're just seeing the future,
There you go.
which is
Very
freaking me
cool.
out. Could I, now look, again, we're not gonna ever really do this, but are the denominators the same?
No.
Did we make them the same?
Yeah.
Hell yeah, let's do that. What does this become? What does this guy need?
A D.
What's the need again? Okay, so give him a and then this guy needs Good, I was hoping somebody. Are the bottoms the same? Yes, can I do the same thing we did up here? What's the answer gonna be?
AD over BC.
AD over BC, I love it.
I just did the fraction wise, the way you had it the first time, because I visualized it better.
Oh, okay, so let me write it again. That's a weird ass way to do it, yes?
Yeah, I can't.
Totally agree. But what's really cool is, how do we do this officially now?
The fraction over fraction.
Well,
Let's-
you never
let's
have to do,
reciprocal.
yeah,
Keep changing
yeah,
it.
reciprocal. And what do you get?
Same thing.
Same thing, holy shit. Which is again, kind of not a proof, but it's a verification that the multiply by the reciprocal seems to work. Well, that sort of is a proof, because A and B and C can mean anything. Okay. Maybe. I like it. Oh, one more thing. I think it's only one more thing. You guys excited about that?
Yeah. He says say that and then. For another 3 times.
One more thing could have 3 parts to it, so we'll find out. All right, I'm gonna erase all this. You guys ready? So let me ask you this: if there were, how do I want to say this? So if you have 20 apples, and you have 5 boxes, right? How many apples can go in each box?
4.
Holy shit. So 20 divided by 5. Jeff, pick away. So this will tell you if you divide what you've got by what you're putting it into, it'll tell you how many can go in each. So, let me see, how do I want it? Yeah. If I see 2 apples, this is my attempt to create a real world example of multiplying by the reciprocal. Are you kind of with me?
You should have had 100 watermelon and 2 boxes for a party that Mike was going to.
I like it. I thought you were like telling me something happened.
No, it's like a problem you would have gotten in that
I'm
math
with you,
problem when you were
I'm with you.
little.
I'm with you. But what I have in my head is this: if I had a box sitting on the ground and half of it was covered, and I saw 2 apples here, and I knew it was full, how many apples are in the box? What's in the box? Yeah, 4. I like it. So 2 apples, and I see half of the box, and I see two apples in half of a box. So I really want you to get 20 apples in 5 boxes is 4. 2 apples in half of a box. So I'm going to do exactly what I did. Divide 2 apples in half of a box. How many are in each box? I'm still going to divide, because that's the physical problem doesn't give a shit that it's a fraction. I really want this to make sense. Yes?
Dividing by half is the same as multiplying by 2, right? Is that?
Yeah, so this is a physical representation. Because even before I write anything, you know the answer is 4. Yes? If you see 2 apples in a full box, right, and you see half the box is 2, then it's got to be 4 apples in that thing, yes? Yes, if the box is full, you see exactly half. You see 2 apples. I mean, this is a big-ass apple. I have no idea. Big-ass apples. There's got to be 4 apples in the damn box, yes? Are you with me? Okay. Now, this was 20 apples, 5 boxes, 4 apples per box. 2 apples, half of a box. I'm going to do the same work to see how much is in each box, because math doesn't give a shit what the number is. The process is divide. So 2 divided by half has to be 4. Right? So that's another indication why multiplying by the reciprocal actually matches up with real life. It took me forever in my career to come up with a physical representation of dividing a whole number by a fraction, because it's not like, and I think this book did something similar. There you are, book. I don't know, somewhere now. Okay, maybe, did you not like that last part much? I'm sorry. It didn't make sense at all? I tried. I said there was one more thing, didn't I? That was it. Yeah. So let's do this. You're gonna really love this. Next Thursday,
Oh.
I'll have a quiz.
Of course.
Let's see. On chapter. Well, what is it? It's actually, we'll do 5-2 through 6-2. How's that?
5-2 to what now?
The camera didn't see that.
How about chapter 2 up to chapter 7? You have to read ahead.
Chapter 9.
Chapter 9? Let's do chapter 9.
Chapter 9.
Or do you want me to do that instead?
That's good.
Alright.
Wait, yeah, there's
That's your option.
a quiz and a speech on the same day
Yes.
again.
Say again?
There's a quiz and a speech on the same day again.
Oh, yeah. No, I talked to your teacher.
Yeah, you can do that.
We try to, we have a big
Speech
meeting.
day till today. You at the beginning of class.
3 times a month we get together and say, when are you gonna, you're doing that, can you do it on this day? Yeah, let's all, okay, now there's 5 things a student, okay, good.
I knew it.
So,
You knew it.
That's why they come
I
up.
knew it.
that's the way things happen.
I knew it. Next Thursday.
Alright, that's enough for today, I guess.
5.2.
Wait, no.
So,
What's up?
there's a quiz.
Oh.
Well, this is on second
He
one,
just,
same
I love it.
class.
Thank you. Oh, yeah, yeah, please don't let me forget.
Wait, Emma.
What is it?
You future. You
Remember
future.
something.
You remember when you were talking and you said.
Yeah,
let
so
us know
just add
early?
it closer.
Later.
We'll have to figure out. When, I need to look to
Emily's got
see,
this
you can
right.
shoot me an email, I can look to see when I'm doing tests in my other classes.
Oh, yeah, I like the practice.
For you to just.
I think it's gonna be a long class, bro.
Thank you.
That's correct.
It's not, it's, they're great.
Got you.
Hey guys, welcome back to my channel. How do you pause it?
You hit, don't know, you better hit the right thing or it's gonna get.